Namaskar everyone. I hope you all are doing well and ready to embark on a fascinating journey towards decoding ancient texts with satellite imagery and mapping. Today, we will explore how modern geospatial technologies like GIS, remote sensing, and satellite imagery can help us better understand and apply the wisdom embedded in ancient Indian knowledge system. Now we will talk about the revealing lost landscapes. Many rivers and cities mentioned in our ancient texts have vanished over time. However, technologies like multispectral satellite imaging have revealed dry river channels, including the debated Saraswati. This supports Vedic descriptions and helps us map historical civilizations with surprising accuracy. Ancient Indian scriptures like the Rig Veda, Mahabharata, and Skand Purana offer vivid descriptions of rivers, forests, mountains, and settlements, some of which are no longer visible in today's geography. These texts serve as time capsules, preserving the memory of landscape shaped by both natural evolution and human transformation. The Rig Veda offers a river like the Saraswati, once a mighty river, now lost or reduced to subterranean flows. Geologists and satellite imagery suggest it may have flowed through present day Haryana and Rajasthan. The Mahabharata speaks of cities like Indraprasth and vast forest belts, some of which have been overtaken by urbanization or climate shift. The Skand Purana, rich in pilgrimage geography, mentions tirthas, sacred lakes, and mountain paths, some of which may have changed due to tectonic shifts, erosion, or sedimentation. These texts remind us that geography is dynamic, shaped by time, climate, and human action. They also offer valuable insights for reconstructing historical ecologies, guiding modern geographers and archaeologists in mapping India's ancient environmental heritage. Now we will see the georeferencing of ancient descriptions. Our ancient texts don't use latitudes and longitudes, but refer to locations in relation to rivers, mountains, and directions. By decoding these clues and georeferencing them, we can create spatial models that align mythology and geography. Let me tell you about a sloka from Skand Purana. पूर्वेण सिन्धुः प्रभवः पश्चिमे च समुद्रगः उत्तरं हिमवन्तं च dakshinam cha mahanidim. This is just an example of converting text-based references into spatial meaning. Ancient Indian texts such as the Rig Veda, Skand Purana, Mahabharata, and various regional chronicles are rich in geographic descriptions. They refer to rivers, forests, mountains, celestial alignments, pilgrimage routes, and kingdoms with remarkably specificity, often mentioning cardinal directions, relative distances, and environmental markers. While these are not maps in modern sense, they form a narrative geography, one that can be decoded into spatial coordinates using geospatial tools. Now, the question is how it works. Scholars extract references to places, directions, and distances For example, 100 yojans east of the Himalayas. Now we will talk about the geohistorical interpretation, which is matched with present day geography through archaeological records, satellite imagery, and toponymic continuity, or you can say the place name retention. The interpreted data is then plotted on a map using GIS software, transforming literary geography into visual interactive layers. So, why it matters? It helps reconstruct lost or mythologized landscapes. It also helps in identifying ancient trade routes, pilgrimage paths, or settlement patterns. It also preserves indigenous knowledge systems in a digital, accessible form. It also bridges literary studies, archaeology, and modern geoinformatics. For example, a reference in the Skand Purana to a tirtha between the Saraswati and Drishadvati rivers allows researchers to pinpoint a location within the ancient Brahmavart region, now supported by paleo-channel studies and remote sensing data as well. Now we will see the mapping sacred and mythological sites. Sacred geography is central to Indian cosmology. From the Skand Purana's mention of Navkhand or 9 regions of the earth to the depiction of Mount Meru at the center of the universe. We can use mapping tools to reconstruct ancient mental maps into digital formats that connects space, faith, and tradition. Let me explain you with the example of Skand Purana, one of the largest and most geographically rich Puranas. This concept of Navkhands, meaning 9 parts or 9 regions, is an important cosmological and geographic framework used to describe the earth. These divisions are not merely physical but are deeply imbued with the spiritual, cultural, and symbolic meanings, reflecting ancient Indian cosmology's holistic understanding of geography. Now we will see the concept of rediscovering ancient water system. Here remote sensing offers an invaluable tools for identifying, documenting, and analyzing ancient water management systems, many of which were designed with intricate planning and often linked to sacred landscapes. By employing satellite imagery and aerial sensors, researchers can uncover long buried or previously unrecognized features such as hidden reservoirs, canals, tanks, and water related infrastructures that played a critical role in sustaining civilizations, particularly in arid or semi arid regions. These ancient systems were not just utilitarian, they often carried spiritual significance and were considered vital to the prosperity and well being of communities. Remote sensing can help us revisit these systems and validate their designs, particularly when compared against historical texts or architectural descriptions. Now we will talk about the identifying hidden reservoirs, canals, and tanks. In many ancient cultures, including those of the Indian subcontinents, water bodies such as reservoirs, canals, and tanks were deliberately constructed as part of complex irrigation and water conservation system. Remote sensing through high resolution satellite imagery or aerial photography can help detect subtle surface features like changes in vegetation, ground moisture, or topography that may indicate the presence of buried or abundant water features. For instance, change detection methods can track soil moisture levels, vegetation health, and land use patterns, revealing anomalies that may point to submerged or forgotten water bodies. LIDAR, which we had already discussed in the previous slides, light detection and ranging technology, when used in combination with remote sensing data, can further enhance the ability to detect and map these features even under dense vegetation cover or soil layers, revealing systems like canal networks, tanks, and reservoirs hidden beneath the Earth's surface. Now we will talk about the studying the urban water planning in ancient cities, for example, Dholavira. One of the most prominent examples of ancient urban water management is the Harappan site of Dholavira, located in present-day Gujarat, India. Dholavira is known for its advanced water management system, which included large reservoirs, water channels, and drainage systems. Using remote sensing, researchers can study the spatial arrangement of these features in relation to the overall urban layout, offering insights into how the city planners managed water for both domestic and ritual use. Satellite imagery can also help mapping the layout of water storage system and their integration with the urban infrastructure, allowing for a better understanding of how these systems function across different seasons and climatic conditions. Here, the temporal remote sensing data can also be used to study how these water systems have changed or deteriorated over time, helping archaeologists track the collapse or evolution of such sophisticated planning. Now, we will talk about the validating ancient water systems described in text. For example, Jalashay in temples. Ancient Indian texts like the Earth Shastra, as well as regional texts describing sacred sites, often provide detailed references to water related structures like Jalashay or sacred water bodies or tanks that were built within or around temples. These texts offer rich descriptions of the design, function, and significance of these water bodies. But the physical evidence of these systems is often difficult to find due to changes in land use or erosion. Remote sensing allows researchers to correlate textual descriptions with physical landscapes. By overlaying descriptions from text with satellite imagery, scholars can identify potential locations for these sacred water bodies and validate whether they exist or existed in the form described. Moreover, the combination of GIS and remote sensing techniques can also help locate these structures within the broader religious landscape, offering insights into how water, as both a physical and symbolic resource, shape the spatial organization of temples, cities, and sacred sites. Remote sensing ability to uncover hidden water systems and validate textual descriptions offer a fascinating intersection between technology, history, and spirituality because it not only adds in rediscovery of ancient water management systems but also helps us understand how water was intertwined with cultural practices, religious rituals, and urban planning in ancient civilization. Through these advanced tools, we gain a deeper appreciation of how sacred geographies were shaped and maintained not just through architectural grandeur but through a finely tuned understanding of the environment and its resources. Now we will see the validating orientation and architecture. Satellite based orientation studies have opened up new avenues for exploring the intricate relationship between sacred architecture, urban planning, and astronomical alignments in ancient cultures. By analyzing the orientation of temples, cities, and other architectural structures using high resolution satellite imagery and geospatial technologies, researchers can uncover evidence of sophisticated spatial planning that aligns with celestial events, cardinal directions, and ancient architectural prescriptions. These studies not only offer a deeper understanding of the built environment but also validate the architectural principles described in ancient texts like the Vastu Shastra, Sthapatya Veda, and other sacred treatises that detail the alignment and design of spaces in relation to cosmic principles. Let's start with the temples aligned to solstices and equinoxes. One of the most striking discoveries through satellite based studies is the alignment of ancient temples to key solar events such as the solstices and equinoxes. Many temples, particularly those in Hindu and other religious traditions, were constructed with a deliberate orientation that synchronized with the rising or setting sun on specific days of the year. This alignment often corresponds to solstices or the longest and shortest days of the year, or equinoxes, or you can say the when day and nights are of equal length. These events were of great cosmological and ritual significance. Satellite imagery can accurately map the orientation of temple structures and their alignment with these celestial events, revealing a conscious effort by builders to link architectural form with the cycles of nature. Let's understand it with an example. The famous Khajuraho temples and Sun Temple at Konark in India exhibit remarkable alignments with the sun, which can be validated through satellite based studies of their axial direction and spatial relationships with surrounding landscapes. Now we will talk about the cities designed using cardinal directions. In addition to sacred spaces, satellite based orientation studies have also illuminated how entire cities were designed with a conscious adherence to cardinal directions north, south, east, and west as prescribed in ancient texts. Cities like Dholavira and Fatehpur Sikri have been studied for their grid like urban layout and precise alignment to these cardinal points. Such designs were often guided by cosmological beliefs that link earthly directions to spiritual or divine forces. For example, the East was often associated with beginning or rebirth, and therefore temples' entrances were often oriented in this direction to greet the rising sun. Through satellite based mapping, the geometric precision of ancient city plans can be measured, demonstrating that these cities were not just functional but imbued with spiritual meaning. The alignment of streets, buildings, and sacred spaces according to cardinal directions reflects a deep cultural understanding of balance and harmony, as well as a desire to connect the physical realm with celestial forces. Now we will talk about the matching textual prescriptions from Vastu Shastra and Sthapatya Veda. Ancient texts like the Vastu Shastra and Sthapatya Veda contain detailed guidelines for the construction of buildings, cities, and temples with emphasis on the alignment and orientation of structures in relation to the natural world. These texts prescribe specific directions, proportions, and geometric configurations to ensure that buildings are constructed in harmony with cosmic energies. Here, satellite based studies allow researchers to compare the actual layout and orientation of ancient sites with the prescriptions outlined in these texts. By using GIS and remote sensing, scholars can validate whether the building plans of ancient cities and temples adhere to the guidelines set forth in these ancient treaties. For instance, the Vastu Shastra suggests that the main entrance of a house or temple should ideally face the east to welcome the sun, and this can be corroborated through satellite data showing the orientation of such structures. Similarly, the Sthapatya Veda emphasizes proportionate alignment, which can be mapped and analyzed for consistency with the physical structure that have survived. Now, these satellite based orientation studies are not merely technical exercises, they represent a profound insights into the ways in which ancient cultures understood and connected to the cosmos. The alignment of temples, cities, and buildings with solstices, equinoxes, cardinal directions, and celestial events reveals a cultural worldview that saw the built environment as a microcosm of the universe. These discoveries validate the ancient architectural knowledge embedded in texts like the Vastu Shastra and Sthapatya Veda, demonstrating how spiritual principles and cosmological beliefs were physically manifested in the design of sacred and urban spaces. So, by combining ancient wisdom with modern satellite technology, researchers can unlock new dimensions of understanding about the sophisticated relationship between architecture, astronomy, and sacred geography. Now, we will see how important to integrate modern tools with ancient wisdom. The fusion of modern geospatial technologies with ancient cultural knowledge is reshaping how we preserve, study, and engage with our heritage. This integration, particularly through tools like digital heritage preservation, cultural GIS, and cross disciplinary collaboration, it opens new pathways for understanding and experiencing ancient wisdom, architecture, and landscapes. By harnessing the power of modern technology, we not only safeguard our cultural legacy but also create immersive, interactive experiences that foster education, tourism, and cultural exchange. Digital heritage preservation is a cornerstone of integrating modern tools with ancient wisdom. This process involves using technologies such as 3D scanning, photogrammetry, and GIS to create digital replicas of ancient sites, objects, and landscapes. These digital models help protect fragile cultural assets that might otherwise be at risk due to time, weathering, or even human activities. For instance, through 3D modeling and laser scanning, ancient temples, monuments, and manuscripts can be digitized, offering an invaluable resource for preservation and study. These digital replicas can also be stored in open access databases, providing a permanent record for future generations and ensuring that even if physical structures degrade or are destroyed, their cultural significance remains intact. Moreover, these digital models can be used for virtual tourism, allowing people worldwide to explore and learn about historical sites without physical interventions, thereby reducing the risk of damage from tourism. Now we will talk about the cultural GIS for education and tourism. Cultural GIS is an interdisciplinary field that combines geospatial technologies with cultural studies, provides an innovative platform for integrating modern mapping techniques with ancient cultural landscapes. Cultural GIS also allows the creation of detailed, interactive maps that not only depict physical features but also incorporate cultural, historical, and symbolic information. By overlaying archaeological, historical, and literary data onto modern maps, cultural GIS help educators, researchers, and tourists understand how ancient civilizations shaped their landscapes and how these spaces were used for religious, political, and social purposes. Now, in the field of education, cultural GIS offers an interactive way to engage students with ancient knowledge systems, sacred landscapes, and historic cities. For example, a cultural GIS map of ancient India could depict the interconnections between sacred sites, pilgrimage routes, and urban centers, enabling students to explore the physical and cultural connections between these places. Similarly, in the realm of tourism, cultural GIS can enhance visitors' experiences by providing interactive, informative maps that guide tourists through historical sites while offering contextual insights into the cultural significance of each location. Visitors can view both historical reconstructions and present day images of these sites. It will help them gaining a deeper understanding of the cultural landscape they are experiencing. So, the integration of model tools with ancient wisdom requires a collaborative approach that brings together historians, geographers, archaeologists, and technologists